Okay, here's the warm-up for 7.5. Debbie solved the linear equation 3 times x plus 4 minus 2 is equal to 16 as follows. Go ahead and put me on pause. Try to figure out where she made her error between what two lines. You should have picked between lines 2 and 3. And the reason why is because in line 2 she had to use the distributive property. Well, that was the property she was attempting to use. 3 times x is 3x, but 3 times 4 would have given her 12. So that's actually where her error was in the algebraic equation. Oops. 7-5, dividing properties of exponents. Dividing powers with the same base. As long as the bases are the same, the rule is that you subtract the exponents. Okay, so if we look at the first example here, which might be hard to read, I'll write it down here. It's 2 to the 6 divided by 2 squared. The way they actually show this, if you wanted to do it the long way, 2 to the 6 means 2 times 2 times 2 times 2 times 2 times 2, 6 of them, and 2 times 2. You would cancel your 2's, and you would be left with 2 to the 4 of them left, which is right here. So it would be 2 to the 4th power. Or you can use the rule, which is take your exponents, and 6 minus 2, which they're showing up here, is 4, which still comes out to 2 to the 4th. So when you're dividing, subtract the exponents. When you multiply, you add the exponents. When it's the power rule, you multiply. Say that right? When you multiply, you add. When you divide, you subtract. And when it's the power rule, you multiply. All right, so let's look at these examples. What is the simplified form of each expression? Y to the 5th divided by y to the 4th. You can either write it all out the long way, or you can use the rule, which would be 5 minus 4 is 1, and that simplifies to y. And the second one, you have d to the 3rd divided by d to the 9th. So that's d to the 3 minus 9 is negative 6. Can't leave it like that, so you have to find the reciprocal of it, which would be d to the positive 6. In the third example, you have k to the 6th, j squared divided by k to the 1st times j to the 5th. So look at your common bases. We have k to the 6th divided by k to the 1st would be k to the 6 minus 1 is 5. And I guess I could leave it. J squared divided by j to the 5th would be j to the negative 3. I'm going to put my 1 under that because I cannot leave my j to the negative 3 with a negative exponent. So I'm going to reciprocate, or reciprocal. My k to the 5th is going to stay because that's not a negative, that's a positive, which is not the problem. It is the one with the negative exponent, which is this guy right here. As soon as you flip it, it's going to take the negative 3 and make it a positive 3. Next one, find the like bases. We have a to the, this says negative 3 minus 5, which would be negative 8. You have b to the 7 minus 2 would be 5. The only one you have to flip is the one with the negative exponent. So the a to the negative 8 is going to drop down and go as a positive. B to the 5th stays because the exponent is positive. All right, here's a big one. We have x to the 4th divided by x to the 4th. Well, that really equals 4 minus 4 is 0. They actually cancel, and anything to the 0 power is 1. I'll leave it like that for now. Then we have y. If you look at the exponents on the y, we have negative 1 minus a negative 5. When you have a negative negative, it's going to push these positive, and negative 1 plus 5 is 4. Z to the 8th divided by z to the 1st is z to the 7th. Know that anything to the 0 power is 1, and 1 times y to the 4th times z to the 7th is, I'll put it in the correct order, z to the 7th times y to the 4th. Raising a quotient to a power, now you're looking at the only difference is we've got a fraction raised to a power. So if you look at the first example, they give you 3/5 and they're raising it to the third. Know that their exponents on the 3 and the 5 are 1s, and that power rule applies to both numerator and denominator. So it's really 3 to the 1 times 3 is 3, and 5 to the 1 times 3 is 3. 3 to the third is 27, and 5 to the third is 125. So it's still the power rule, just make sure you apply it to everything within the parentheses. So let's try some examples. We have y to the third, ignore these little dashes up here, that was from my snapshot, not done so well. Y to the third divided by y to the 10th would be y to the 3 minus 10 is negative 7. You're going to have to flip it and turn it into a positive 7. Number 2, this third power is applying to both numerator and denominator, so we're going to have x to the 4 times 3 is 12, power on a power, and 3 to the first raised to the third would be 3 times 1 would be 3. So we end up with x to the 12th divided by 3 to the third is 27. Going to number 3. Please stop me, put me on pause, try a problem, and then bring it back to see if you're getting it right. This one, you have a negative exponent on a fraction. So in order to turn this into a positive 3, you actually just flip the whole thing. Find the reciprocal of it, and now we'll turn it to a positive. I'm going to put my little imaginary 1s in there and know that that 3 is a power on a power, so it applies to both. And my final answer is n to the third divided by m to the third. In number 4, I have a negative exponent again out on a fraction, so I'm going to flip it to 5y to the 4th divided by 3x squared, raise it to the positive 4th because I did the reciprocal. Now I'm going to apply it to every single one of these in here, so be careful. So I have 5 to the 1 times 4 is 4, y to the 4 times 4 is 16, 3 to the 1 times 4 is 4, and x to the 2 times 4 is 8. So 5 to the 4th power is 5 times 5 times 5 times 5, which is 625. Y to the 16th, I have no negative exponents now, so I'm good on that. 3 to the 4th power is 81. X to the 8th, these are different bases, and 625 and 81 are not divisible by any same number, so I'm done. Scientific notation. It says, during 1 year, Honduras had a population of 7.33 times 10 to the 6 people. The area of Honduras is 4.33 times 10 to the 4th miles squared. What was the population density? In other words, how many people lived within a square mile? So what you really want to do is take the number of people and divide it by how many square miles there are. When you do that, you're going to end up with a scientific notation divided by scientific notation. Now, we're going to have to estimate this because 7.33, if you take your calculator and divide it by 4.33, you're going to end up with a long decimal. So we're going to round it off to the nearest hundred, so it's going to be about 1.69 times 10. And now this is where the property applies for the lesson. 10 to the 6th divided by 10 to the 4th means you subtract your exponents, and 6 minus 4 is 2. This is written in scientific notation. You can leave your answer like that, or you could actually move it over and change it back to standard, and therefore say 169 people per square mile live in Honduras. And that would be it. That takes care of 7.5.